In this section, we're going to go on and talk a little bit more about math, understanding, solving, and explaining. We'll look at conversions and stuff like that today. So there's a 3-step problem-solving process that we can use each time we solve a problem to make sure we do it correctly. First of all, understand the problem. Second, solve it. And third, explain. And during the third one, when you're explaining, make sure that your answer makes sense. Okay? If you come up, like say, you've got a shirt that was $20 and it asks how much is it after tax, and you come up with an answer that's $3, then you've done something wrong because obviously it's going to cost more than $20 after tax. So make sure that you check your answer. When you're understanding the problem, think about what the problem asks you to do. Remember that drawing diagrams can often help you make sense of a problem. Ask yourself what the solution should look like what unit should it be in and all. And should it be bigger than the numbers or smaller? Try to map a path, either mentally or in writing, that will lead you from your understanding of the problem to its solution. And as you move on to steps 2 and 3, continually revisit your understanding of the problem. Step 2, when you're solving, obtain any needed information for the data, like maybe a conversion scale. For multi-step problems, be sure to keep an organized, neatly written record of your work, which will be helpful if you later need to review or revise your solution. I stress this importance with all my students. A lot of students who don't want to write down their work. They want to try to do it in their head or just straight on their calculator. That may be successful, but sometimes it may not be. So if you write it down, then you're more likely to get a correct answer. And if you get an answer that doesn't make sense, you can look back at the work you've written and kind of try to figure out where you might have gone wrong. Well, if you're just trying to think of it all in your head, it's hard to keep up with that. Double check each step as you work to avoid carrying errors through the end of your solution, and constantly reevaluate your plan as you work. And last, when you explain, be sure that your result makes sense, as I pointed out a minute ago. Once you are sure that your result is reasonable, it's a good idea to recheck your calculations once more, or even better, find an independent way to check your result. Especially on tests, always double check to make sure you haven't gotten, calculator error where you've put in the wrong number by accident or something like that. Identify and understand any potential sources of uncertainty in your result, and write your solution clearly and concisely using complete sentences to make sure the context and meaning are clear. Okay, so units. Units of a quantity describe what that quantity measures or counts, like feet or meters or ounces or miles or pounds. Unit analysis is the process of working with units to help solve problems. So here's an example. You're buying 30 acres of farmland at $12,000 per acre. What is the total cost? Well, if we go through our steps, the first step, and I'm not going to write this down, I'm just going to walk us through it. The first step would be the question asks about total cost. And one of the given units is dollars. So we expect, since it's cost, that the answer is going to be in dollars, right? So let's look at solving it. The key word of suggests multiplication. And we realize that we can end up with an answer in dollars by multiplying the acreage by the cost per acre. Now, again, a lot of you are going to want to just multiply in your head or multiply in your calculator and be done with it. But if we get used to writing this down, then when the problems get bigger, because they will, you'll have to do more than one conversion in a problem, then you'll be used to it and it'll come more naturally. So, we're trying to take 30 acres and get out some cost of all 30 of those acres. Now, we know that the land is $12,000 per acre. So we're going to multiply, like we said, since of implies multiplication. And we need to make a fraction that helps us finish this out, that helps us multiply. So our conversion fraction would be $12,000 and 1 acre. The next thing to consider is what goes on top and what goes on the bottom, the $12,000 or 1 acre. Well, if you look here, this acres, I'll say, is on the top because you could put a 1 under it, right? So your 1 acre needs to go on the bottom and the $12,000 on top. The reason for that is because you want your acres to cancel out. If you have acres over acres, that cancels out, right? Just like if you had 3 over 3, you get 1. Acres over acres is 1. It's canceling. And so, again, we're just going to multiply 30 by 12,000, and we get $360,000 for these 30 acres. We found that the land cost $360,000 and noted that the answer has come out with the units we expected. It's come out larger. We expected that. Okay, if 1 acre is $12,000, then 30 acres better be more than that, right? If we came out with a smaller number, we know we've done something wrong. Unit analysis and problem solving. Remember, you cannot add or subtract numbers with different units. So you can't add feet to inches. That wouldn't make sense. But you can combine different units through multiplication, division, or raising to powers. It's easier to keep track of units if you replace division with multiplication by the reciprocal. So we'll look at that. For example, instead of dividing by 60 seconds over 1 minute, multiply by 1 minute over 60 seconds. So it just depends on what we need to cross out. We'll focus on multiplication. When you complete your calculations, make sure that the answer has the units you expected. If it doesn't, you've done something wrong. So make sure that things cross out like we did before. Some key words. Of means multiplication. We've already discussed that. Per means division. So if you see miles per hour, or miles divided by hours, that is miles per hour. Again, of is multiplication. Kilowatts times hours, we write as kilowatt hours. That hyphen in there is just a hyphen, not a minus, by the way. If you hear the word square, that means we're raising to a second power. So that would be like feet times feet is feet squared. Or we could say that is square feet. And cube or cubic means raising to the third power. Feet times feet times feet is feet cubed. Or we could say that is cubic feet. Example 2 says, how many crates do you need to hold 2,000 apples if each crate holds 40 apples? So you're trying to find out how many crates. So your units for your answer would be in crates. And it says each crate holds 40 apples. So that implies that 1 crate holds 40 apples. So we're trying to take 2,000 apples and we want to multiply by 40 apples and 1 crate. We need to put apples on the bottom and 1 crate on the top so that our apples will cancel out. Then we just take 2,000 divided by 40, and that gives us 50 crates. We'll need 50 crates to hold 2,000 apples. 12 inches equals 1 foot is a conversion factor. You can write it as 12 inches over 1 foot or 1 foot over 12 inches. Either way will work because they'll both end up as 1. They both mean the same thing. Same thing with 24 hours in 1 day. You can write it either way, whichever way works to get you through your problem. Example 3 says, convert a distance of 9 feet into inches. Okay, so we're starting with 9 feet and we're going to inches. Now, inches is a smaller unit, so we expect to get a bigger number, first off, and we expect our answer to be in inches. And the conversion factor with feet in inches is that there's 12 inches in a foot. So, feet, we're starting with feet, and it's on the top, so 1 foot needs to go on the bottom, 12 inches on the top. That allows us to cancel out our feet, and 9 times 12 is 108 inches. Another example, how many seconds are in 94 days? So we're starting with 94 days, and we want to end up in seconds. And seconds is smaller, so we expect to end up with a lot of seconds, right? And so we need to go through several steps of a conversion process here. I don't know about you, but I don't know off the top of my head how many seconds are in a day, by any means. But I know how many hours are in a day, and I know how many minutes are in an hour, and how many seconds are in a minute. And that gets me to seconds. So we're going to go through this process to get us all the way there. So we know that there are 24 hours in 1 day. 1 day needs to go on the bottom so that it will cancel out. So our days have canceled. Now we need to get rid of hours. There are, when we'll go down to minutes, there are 60 minutes in an hour. Since 1 hour was on top before, and the next fraction, it needs to be on the bottom. 1 hour is 60 minutes. And that makes our hours go away. And last, let's get to seconds. We know that 1 minute has 60 seconds. Minutes needs to go on the bottom. 60 seconds on top. And our minutes will go away. And so, get rid of that for a second. We'll take 94 times 24 times 60 times 60, and that'll give us how many seconds? Notice how we're left with seconds. That didn't go away, and that's what we want. So that is 8,121,600 seconds. And we got a bigger number as we expected. We're in seconds. We should be good. What if you've got to perform a conversion with raised powers? Well, 1 yard squared, we know that 1 yard is equal to 3 foot. But 1 yard squared is not equal to 3 feet squared. We have to break this down. 1 yard squared is the same thing as 1 yard times 1 yard, which would be 3 feet times 3 feet. 3 times 3 is 9, and feet times feet is feet squared. And here's a picture to help you see. Yes, 1 yard is 3 feet, but if we're squaring that, then we end up with 9 feet squared. So example 5 says you want to carpet a room that measures 12 feet by 15 feet, making an area of 180 square feet. But carpet is usually sold by the square yard. how many square yards do you need? Well, this is an example where we could easily draw a picture. Our room is 15 feet by 12 feet. And the area, I'm just going to put in the middle, is 180 square feet. Okay? So we're trying to go from 180 square feet to square yards. And we just discovered that our conversion factor for this is that 1 yard squared is equal to 9 feet squared. So feet need to go on the bottom. 9 feet squared. And yards can go on the top. Our feet squared go away. And we're dividing 180 divided by 9. How do I know I'm dividing? Because on the top is a 1 and on the bottom is a 9. So since there's a 9 on the bottom, that means I'm having to divide. We end up with 20 square yards. Example 6, how many cubic yards of soil are needed to fill a planter that is 20 feet long by 3 feet wide by 4 feet tall? A planter. Well, a planter is one of those things that you put flowers or vegetables, something in, right? So I'm going to draw us a planter. It might not be drawn to scale, but maybe it'll be fairly close. There we go. So we got a planter, and in our planter, we're going to put some flowers. I need a different color for the flowers. Oh, I've got yellow. There we go. Okay. And we're told that it's 20 feet long and 3 feet wide and 4 feet tall. And we want to know how much soil is needed to fill it. Well, yeah, I realize that usually you don't fill it all the way to the top, but we're going to assume that to keep from making this more complicated, okay? So what we need to find first is the volume. Remember, volume is length times width times height. So we'll take our length of 20 feet, multiply it by the width of 3 feet, and multiply that by the height of 4 feet. That gets us 240 cubic feet. Now, we're supposed to change cubic feet into cubic yards, right? And we know that there's 3 feet in a yard, but again, we can't say that 3 cubic feet is equal to a yard. That's not acceptable. Okay, so what do we need to do? Well, we'll go up here. We've got, to get yards, we've got a foot. Let's see. 3 feet times 3 feet times 3 feet. That's 3 times 3 times 3 is 27 feet cubed. That is equal to 1 yard cubed. So for our conversion factor, we'll put 27 cubic feet on the bottom and 1 cubic yard on the top. That allows our cubed feet to go away. And again, In this case, we need to divide. 240 divided by 7 is approximately 8.9. So 8.9 cubic yards of soil. Currency conversions. Converting between currencies is a unit conversion problem in which the conversion factors are known as the exchange rates. So we know that if we have $1 in the United States, that doesn't mean the same thing as a, say, peso in Mexican, yen in Japan, or even a Canadian dollar. Okay, it's all a little bit off, and the conversion rates change fairly constantly throughout the world. But this is the conversion rates that we're going to use, that were the ones that were in our book at the time it was created, are the ones that we're going to use, or unless my math lab tells you something different, okay? So this is saying that the British pound, $1, $1 American dollar, is equal to 1.624, or no, let me make sure I'm saying that right. No. $1 or $1.624 is equal to 1 British pound, or over here, 0.6158 British pounds is equal to $1. So you could use either of those conversions when you're working these. And for example, Canadian dollars, 1.005, so it's very close, American dollars is equal to 1 Canadian dollar, or 0.9950 Canadian dollars is equal to 1 American dollar. So example 7 says, a gas station in Canada sells gasoline for 1.34 Canadian dollars per liter. What is the price in dollars per gallon? American dollars per gallon, that is. Use the currency exchange rates on the previous slide. Okay, so we've got 1.34 Canadian dollars is equivalent to 1 liter, right? It's 1.34 Canadian dollars per liter, and per means division. So this is a conversion factor in itself. So the first thing we want to do is change Canadian dollars to American dollars. And we know that 1.005 American dollars, I'll write this up here, is equal to 1 Canadian dollar. Okay? So, Canadian dollars needs to go on the bottom so it'll cancel out. And we've got our conversion factor there where Canadian dollars will cancel. But we also need to go from liters to gallons, it says. So let's see. If you look on the conversion sheet that I've included with this section, then you'll see that 1 gallon is equal to 3.785 liters. So this time, liters needs to go on top, because liters was on the bottom there. It's got to go on the top, 3.785 liters, and 1 gallon will be on the bottom. So what have we got here? We've just got ones on the bottom, so we're really just multiplying straight across. We end up with $5. Oh, I forgot to mark out my liters. $5.10 per gallon. So notice we end up in American dollars and gallons. And that concludes this section.